where you will ask your questions. So no worries on that part as well. Apart from that, I see a lot of you guys are joining in now. So guys, please do answer these three questions for me. Number one, what is your name? Number two, where are you currently located in the world? And number three, what are you currently doing in your career? Claudio, like I mentioned, we will not be picking up the questions during the start of the session. We will be picking up the questions at the end of the technical portion of the particular session we have. But even after the technical part is ended, guys, make sure that you stay till the end, because we will be discussing about the certification, the different certification exams itself, and breaking them down into the different percentages of the different topics that are coming, and so on. So guys, again, make sure you stay till the end. You ask all the doubts and questions you have, and we want to make sure that you are kind of learning as much as you can, and all your questions are being answered on that part. So again, guys, please do introduce yourself in the chat window. I see a lot of you guys have already did it. We've got people from Malaysia as well. Welcome, Sresha. I hope I'm pronouncing your name right. I'm really bad with names, guys, but please do mention all your doubts, all your questions, and we will try our level best to pick up as many questions as we can. The people who don't know the three questions I'm talking about, number one, what is your name? Number two, where are you currently located in the world? And number three, what are you currently doing in your particular career? The timer hits 0 and we are live with our brand new session on Docker and Kubernetes for beginners with certification. Guys, again, I have mentioned this a little while ago as well, but all have been asking us for a particular session on this particular topic, and we at K21 Academy, your favorite cloud learning platform, we learn cloud from the experts, always listen to you guys. So we have I'm sorry, brought this particular session for you guys. My name is 𝐂𝐿𝐮𝐻. I'm a community manager at K21 Academy, and I'll be your host and moderator for today's session. Before we start, I want you guys to keep two things in mind. Number one, that you have to be very focused. We have a lot of different things. Just a second, guys. I'm sorry. Okay, I'm sorry about that. We have a lot of things that we will be covering today, both from the technical and non-technical end. When I say technical end, that means directly the core concepts and the proper function, and non-technical end, the things like the certification exam itself, the job market, the opportunities that are out there, and so much more. So you have to be very focused on that. And if you guys have any questions, you have to ask all those questions directly in the chat window as well. Please do not refrain from asking your questions, because it will benefit you a lot if you ask your questions, because we will try to answer all of them. And when I say all of them, that means each and every one of them. As for that, I believe a lot of you guys would be concerned about whether the recording would be available to you guys or not. So as of now, I don't think the recording would be available, but if a lot of you guys want to have the recording, and if my team eventually give me some other news on the part whether the recording would be available or not, we will definitely let you know. But do not worry on that part, because we do have a special surprise as to how you can further or take this one step further in terms of your learning journey in Docker and Kubernetes. But I will be telling you that quite literally at the end of the session. So you have to stay till the end of the session, because all the things that will be covered in the session are going to help you in one way whatsoever. So please make sure that you are not missing out on anything. Okay, so let's start now. Without any further ado, let's have a look at what we will be learning today. First, we're going to start with containers. Then, why imagine containers? What is Kubernetes and why to use it? Feature of Kubernetes. Then there's going to be there are two actually demos. So demo number one, deploying an application using container. Then demo number two, that will be deploying a running application on Kubernetes. We will also be looking at the different Kubernetes certifications and why it is important to actually have those certifications to get a higher paid job, and what difference do these certifications make. We also, when I talk about Kubernetes certification as a whole, we will be looking at two different aspects of the certification. Number one, what is the percentage breakdown of the different topics that are there? And number two, what are the different details about the certification, like the mode of the certification in which it is taken, certification exam, I mean. How much is the validity of the certification? What is the price that you have to pay to give the certification exam, and so on. After that, we will also be looking at the roles and responsibilities of a Kubernetes expert, why you should be and who should be learning Kubernetes. Then we will also be looking at the career, job opportunities, and different market trends on Docker on Kubernetes that is currently going on. And in the end, we will be looking at what is the best way for you to learn Kubernetes, whether it is in the application space or whether it's the other different parts that we will be looking at. In this particular section, we will be looking at a proper detailed learning path. Now, what is learning path? We will be covering that in a bit, but I'll give you a little brief on that. A learning path is the best possible way in which all the different topics that you need to learn and practice for you to not only clear the certification but also get your desired job is given to you on that. So before we do start out, get on to the next one, I would like to welcome you all. I see a lot of you guys have joined us, all of you guys have joined us from different parts of the world. So I'm really glad to see that, and all the very best as well on that part to the people who are just starting out your career. Now, let me tell you a little about our expert trainer for the evening. We have got Rohan today with us. He's got 18 years of IT experience as an architect. He's a Kubernetes and CF certified trainer. He's a certified Kubernetes admin. He's also a certified Kubernetes application developer and certified Kubernetes security specialist. I'm sorry. He's also a Red Hat certified system administrator, and he's also a certified Scrum Master. All of these certifications that we are talking about, majority of them, the certification badge is itself posted on the slide itself. So now, guys, very great or good job, I would say, introducing yourself. I see majority of you guys have already done that, but please do mention whether you are a beginner or an intermediate or an expert directly in the chat window. I'm looking at the chat window as I go. So please do mention, are you a beginner? Are you an intermediate? Or are you an expert at Docker and Kubernetes? Okay, I see 2 beginners, 3, 4, 5, 6. Okay, great, guys. Everybody, I see a lot of you guys are beginners. So great, guys. Because again, if you are a beginner, this particular session is going to be very, very, good or beneficial for you guys. Because a lot of these things that we will be teaching you guys today are from a perspective that if you're a beginner, you're going to benefit from that quite greatly. Kamal, that is a topic that we'll be covering, so don't worry on that part. Okay. Again, for the last time, I'm going to mention this. Let's make this workshop interactive like you're making it right now, with constant, answering the questions that I'm asking and all of that different things. Please do ask all your questions, all your doubts in the comment section, and we will be picking them up. Asim, yes, we do have a course on Python. If you are interested in that, please do just drop down your contact details. That is your phone number and your email, and somebody from my team will definitely contact you there. We do have a person over here with us as well. So definitely somebody from my team would contact you on that if you are interested. But I will be giving the access over to now our trainer for the evening, and we will be picking the session up from now. Hello, sir. I hope Audible, so you have to unmute yourself.
Yes, yes, Shivansh. Just trying to.
Ye- Your screen is visible, sir, and you're audible.
Thank you. Just give me a quick 1 second, please.
Sure, sir. Raj, this is the chat window in which you just mentioned this particular message that you're not seeing the chat window. This is the chat window. So no worries on that.
All right. Thank you so much, Shivansh. Quickly confirming you can see my screen okay?
Yes, sir.
Awesome. Hello, everyone. Welcome to today's webinar. What we're going to discuss right now, we looked at from the chat. What I realize is most of us are beginners here. We will try to understand what is containerization, what is Docker containers, how do we run that, what is the advantage of Dockers. And from there, once we have fair understanding of that, we will have a quick demonstration, making use of some container. We will deploy some application, maybe Jenkins as an example, and we'll try to look at how easy it is when you set things up using your containers. And once we have fair understanding of that, we'll move forward and we'll try to look at why do we need an orchestration tool, and in specific, why do we need really Kubernetes? What is the specialty about that, and how we can set things up, and how we can deploy your application using Kubernetes. What is that superpowers that Kubernetes brings to my table is what we will look at today. We will also have a demonstration at the end where we will deploy some game or some application on a Kubernetes cluster, and we will look at different superpowers of Kubernetes like self-healing or scaling and auto-scaling and stuff around that. So without further ado, let me get started. And let's look at how things were. And before we try to understand what really Docker is all about, what is your containers, if we want to understand what containers are all about, if we understand how things, or before if I understand what is the Docker tool or what problem is Docker trying to solve, if I have an idea of what problem is this container trying to solve me, understanding that tool makes it more easier. Learning that tool becomes more easier for us, right? The couple of problems which is haunting the computing world is what containers try to solve us. One of them is isolation. Isolation and density. What do I mean by that? If I want to run a lot of applications on one server to utilize the computing power I have, the CPU, the memory, and all of that, if I take a lot of applications and I start deploying on that server what I have, the apps might not work correctly. We have multiple applications, maybe different applications using different frameworks, different technologies, different libraries and binaries. They might step on each other. So what do we want? We want the density, as in to run a lot of applications out there. But when we want to go for density, the isolation also needs to be taken care so that the application don't step on each other. So what did we do traditionally for this isolation before we got into the container world? Let's take a step back and look at how things have evolved over time. Traditionally, in the early 80s and early 90s and late 80s, the way we wrote our softwares, the way we deployed our softwares was on physical servers, or bare metal servers, as we call them, physical infrastructure. In the past, we did not have enough technology to run multiple business applications on a same server in the open system worlds of your Windows and Linux. And as a result of that, every time business wanted some business application to be deployed, the IT team would go and procure a brand new server, stack them, rack them up in your data centers, physical servers, and that is where you would deploy your applications. Here is a scenario. So the IT team would always go and look for the capacity. Maybe the architect would plan and tell, okay, this is what my application is all about. And this is the kind of hardware what I'm looking at. This is the kind of compute and memory power what I'm looking at. And IT team would factor in all of that. And it would maybe also factor in the future growth and do the capacity planning and go buy a larger and a big server. Because in the end of the day, if you buy an underpowered server and which is unable to execute your transactions, it will result in loss of revenue and losing your transactions and customers. That is the last thing what the business want. So IT would go procure large systems for you, systems which would not be maybe 100% utilized or maybe utilized to fullest of their capacity. When we factor in the growth and all of that, when we buy a larger server, maybe they would get utilized 5 to 10% on a given day. Or maybe when we have the peak load, they might get utilized, say 20 to 30% of the capacity what we have. And even though I have the spare capacity, I want to go and deploy another business application on top of that. We did not have enough technology to provide that isolation where these applications don't step on each other. And as a reason, what the business would do or the IT team would do is every time the business asked for a brand new application to be deployed, we would go procure brand new physical servers. And the way we were writing our applications were also in a monolith architecture. When I say monolith, the word monolith, which refers to like a large block, the way our softwares were written as a large block, the whole big software what we had was written as one code base, which would get deployed and shipped and run as one unit. And the kind of architecture development process what we made use of was a waterfall model is what we used. And over time, VMware Inc. gave us the gift of virtual machines, which overnight changed the IT into a better place. They gave us a tool called as an hypervisor, making use of which we could go now make use of that underutilized server, which was sitting out there in my data center. Even though it had spare capacity, I could not deploy another application on them because I did not have that isolation out there. Now, making use of this hypervisor, I could go create virtual machines from the application process point of view, just like how my physical machine would look like. My physical machine had its host name, its IP address, its file system, its port range. These virtual machines also had the same thing, but they were not physical in nature. They were virtual. The spare capacity, what was sitting out there in your data center, was taken, virtualized, and you had sliced it up and created virtual machines. These virtual machines as well, from the application point of view, looked and felt exactly like your physical machines, just like the way your physical machines had your file systems, your host names, your operating systems, your IP address, port range, your virtual machines also had that. You wanted the isolation. The spare capacity was out there. You no longer had to buy a new physical server. Of course, if we run out of the physical capacity, we will definitely go add physical server there. But what we're talking about right now is you had some spare capacity, you could not make use of it. Now you can, with the help of hypervisors, which created this virtual server, which sliced up the spare capacity and created those virtual machines. Virtual machines provided those isolations. These virtual machines are so isolated. So if I create a virtual machine 1 and I deploy some application on top of it, and I have a virtual machine 2 and I deploy some application inside that, those both can't see each other. They are completely separated, physically still running on the same physical server you have, the same physical hardware you have. They were running inside two different virtual machines. Virtual machines are awesome. They give you the isolation what you want. And over time, the way we were writing our softwares were also changing. From a monolith architecture, where all of our application was built as a single unit, deployed and run, things were changing. We were moving towards multi-tier architecture. Say, traditionally, if you look at a software, it has a UI or a user interface. It has some business logic in between, and you have some stateful part like a database to store your transactions. Now, the software was kind of broken down into three different applications. One was doing the UI, another was doing the business logic of computing in between, and third was database. Now you had, if you were developing these is three different components, each one of them may be running three different operating system itself. My database is running on Linux, my UI is running on Windows, and the middleware is running on some other version of Linux. Traditionally, what I had to do is go by physical servers. Now I don't need to do that. I have virtual machines and I deploy my applications on top of them. Each virtual machine is so strongly isolated that each virtual machine can have its own operating system. Virtual machine 1 has Windows, virtual machine 2 has Linux. Doesn't matter. They are two completely isolated entities out there, managed and created by a software called as hypervisors. There are a couple of types of hypervisor, type 1 and type 2. Type 2 are the ones which usually runs on your host machine, which provide a host operating system. On top of that, the hypervisor runs and helps you create and manage those virtual machines. That is how virtual machines gave us that isolation so that you could run multiple applications and don't have to really go buy new physical servers if you have the spare capacity out there. Virtual machines are awesome. We still make use of them. They're very cool. But the way we were writing our softwares were also changing. With AWS, maybe in early 2013, coming out with cloud computing and making the modern day cloud computing very popular, the way we were writing our softwares also were changing. In the traditional world, the time to market for the software was longer because everything was kind of deployed as one unit. So if one component breaks or one component is what we have to change, it would impact all the other components because that would all get shipped together, deployed, and run together. Now things were changing. From a multi-tier architecture, we were moving towards microservices architecture, where your large application is broken down into multiple tiny, smaller applications. Each has its own standalone application as its own. Of course, together, all of these microservices make one meaningful application, but every component, every single component of our application was broken down, and to put it in the layman term, we can call it as like a small applications, like mini applications. Now, one large application, what we had, and we broke it down. For example, we converted them into 20 small microservices, mini applications. Each The advantage of microservices architecture was each component could be now built separately by different development teams. And you had the luxury of choosing different kind of software languages if you want to. You could make use of one service to build in Java, another in Python, another in Golang. You could scale them separately. You can build them separately. You can test them, ship them, run them separately. Together is what you have the meaningful application. These microservices interacted with each other, and that's how the end user had an application which was useful for him. Now, when we have so many applications out there, small, tiny applications, and the original attempt to get that isolation, what we looked at was the virtual server. So if I start creating many virtual machines and start deploying these small applications because I need that isolation, if I take all of these 20 microservices and put it on one server, say for argument's sake, just for argument's sake, all of these are built on different versions. Say from Java 1 to Java version 11, I have 11 different components, each requiring a different binary, each requiring a different version of Java. If I take all of these 11 different microservices I have, put it on the same server, things are going to break. One of the microservice needs a specific library or binary, which is not needed for another service. If I upgrade one component, it's going to break for others. So these applications are going to step on each other. Or there can be one application, one microservice, one mini application we have, which needs a lot of resources, like compute, like memory. It can be heavy workload based machine or application, which can start consuming all the resources what I have on the server, starving the others of the compute. What do we do? Well, we need the isolation so that these applications don't step on each other. The original attempt was to make use of virtual machines. If I create different virtual machines, say the example we looked at was 20 microservices is what we created. And if I take all of them and put them on 20 different virtual machines, they work fine. I need the isolation. But the problem is the virtual machines come with some overhead. What overhead? Few minutes back, I was praising them. They are good. They are awesome. But the overhead, what I have is every virtual machine needs an operating system of its own. So what? What's the big deal? Well, they give me the isolation, but I have the overhead of the operating system as well. So if I create 20 virtual machines for deploying these 20 microservices, different applications I have, so that I get that isolation, what I'm going to do is I'm going to end up spending money on the 20 operating system licenses for those machines. Every machine, when I install an operating system on that, every virtual machine, that operating system to run optimally, we need to provide some resources like some memory, some CPU, some disk space out there. And then on top of it is where I'm going to deploy my mini application, that small application, what I have. In the end, what's going to happen is these virtual machines are going to consume more resources than what my application really needs. If my application needs like maybe a couple of hundred of megs of memory to run, fine. I create a nice virtual machine because it gives me the isolation. That virtual machine might consume 4 gigs of memory for me, just using this randomly as an example. So virtual machines give you the isolation. When you are broken down your application into a lot of small applications, it, it adds into a lot of overhead. It is going to cost you the antivirus licenses, your operating system licenses. You need to have a team to maybe perform system hardening, keep your systems up to date, perform your patching, vulnerability scans, and stuff like that. That's going to need larger manpower. That's going to cost you more money and more resources. That's where containers come into picture. Containers do not have the overhead of an operating system. They give you an environment, just like how my physical server was, which had its IP, port range, host name, file system. Virtual machines also had them. My container also has a host name, a file system, a port range. From the application point of view, it doesn't matter if it is running in your physical machine or your virtual machine as a container. Inside your container, it is going to behave the similar way. Containers give you that isolation, and they take away the overhead of a guest operating system. Virtualization is a method of hardware level virtualization, whereas containerization is a method of operating system level virtualization. What do I mean by that? The meaning is, when you have your operating system, you have your server running on there. If I drop my applications and deploy on them, all of them might step on each other, things might break. But if I create some silos, some boxes, and drop my applications inside them, and if these applications can't see anything outside beyond that box, beyond those boundaries, and they can only see what is there inside, that solves my problem. That gives me that isolation, and that server where I've dropped this box or this container, that server can also be running multiple containers. There are multiple applications running inside those containers, and all of those applications can't see outside that box. So you get the density as well, you get the isolation as well, and minus the overhead of a guest operating system. That's what containers are. That is what they are so popular. You don't need to spend your resources on setting up different virtual machines for that isolation purpose. They give you the density, they give you the isolation. And apart from that, running your applications in container has a lot of productivity as well. It's much easier to set up and run your applications on containers, and they consume very less resources compared to your virtual servers. They consume very less time to set up, boot, and run as well. Deploying and running your applications in container takes very less time compared to putting them and deploying them on your servers. That's why the containers are so popular. Moving on from here, now that I just wanted to spend little time explaining this concept because I saw most of us are beginners. Moving on from here, just if I have to show you an example or a difference between the monolith and microservice architecture. On the left-hand side, we have a diagram which talks about it's a monolith architecture out there. All of the system components are all deployed as one unit, one code base, built together, deployed together, shaped and run together. On the right hand side, you have broken down this large monolith application into smaller services of their own, each one acting like a mini application of its own, deployed and run together. Together is what you have a meaningful application, but now you have the luxury of building these components, building these services using whatever languages you want, using different teams, scaling them in need each component. And if you want to do any modifications, you want to do any updates, you can just pluck out one component, modify it, and put it back without disturbing all of them. That's the kind of advantage what you get with the microservices architecture. Long story short, large application, one single unit, broken down into many small mini applications. That's where we looked at another difference between your virtual machine and your container. On the left-hand side, we have the hypervisor. We have the physical hardware here. On top of it, we have a hypervisor which is going to create and manage many different virtual machines. Every virtual machine is so isolated from each other. VM1, I have some applications. Doesn't matter what's going on in VM2. I upgrade some components here. It is so strongly isolated. What is happening on VM2, VM3, I do not have to worry. Every virtual machine needs to have its own operating system. VM1 here is running Windows, VM2 is running Linux, VM3 is running some other version of Linux, maybe Ubuntu or CentOS. works absolutely fine. On the right hand side, we have Docker containers. We have a host operating system. On top of it, we have installed Docker engine. Just like how I have a physical server, this is an example of a type 1 hypervisor though. You could also have type 2 hypervisors, which also require a host operating system on top of it, where we install the hypervisor. One of the popular example, if I have to tell, is maybe workstation or VirtualBox, what we have, which we most commonly use to spin out our virtual machines. Those are the type 2 hypervisors. Cut to Docker, we have Docker engine, which is going to create these boxes, these containers for me. These containers are going to have its own file system. These containers are going to have their own host name, own port range, own IP address, all of that. Who is creating and managing them? That's your container software. That is a Docker engine. And minus the overhead of the guest operating system. So the next logical question is, what do my applications do? They need to do the system calls. They need to talk to the physical hardware under the hood. They need to talk to the kernel. Of course, they need to. And what do? Is they share on whichever host they're running, they're going to share that machine's operating system, that machine's kernel to talk to your hardware. So on the left-hand side, if you look at it, if I have 3 different applications and I want to deploy them on 3 different servers here on the virtual machines, I would be creating 3 different virtual machines, installing 3 different operating systems on them, performing the hardening and patching and scanning and vulnerability and all of those on 3 different machines. On the right-hand side, all I have is one machine, and I'm just paying for one operating system license here. All of those, what I had to do multiple times, I'll just do it here and deploy my containers, deploy my applications inside those containers, which will provide the isolation. The isolation in the virtual machine world is very strong. What do I mean by that? Well, I have 2 virtual machines and I can have 2 different operating systems running out there. Works fine. But when it comes to containers, a subtle drawback, can't say drawback, it gives you a lot of overhead though. The only requirement is the kind of containers what I can run on this machine, which is going to share the operating system, all the containers, they have to be of a similar type. What do I mean? If I have Linux operating system, Linux-based applications, I can run those Linux containers on this host. If I have a Windows-based workload, so I'll have to have a Windows server because the kernel is being shared. Whereas in case of virtual machines, you have the luxury of installing whatever applications or whatever operating systems you want. Virtual machines, like I said, are great, still being used. For that isolation, if you want the virtual machine, it's going to come with a lot of overhead. That is what your containers are going to solve for you. If I want to quickly give you an example, if you have, say, 100 Windows-based applications, for example, each one of them running on their own server, we have 100 virtual machines and 100 Windows licensing is what we need. Instead, I have a large Windows server and I containerized all my application workload and I deploy them as 100 different containers. Only the licensing what I need is for one Windows server, saving me the 99 licenses out there. One of the example is what I can think of. That is the advantage of those containers. They give you the isolation where you can run these independent applications out there and you can run them in a much better way, takes it less time, utilizes much resources, and spins out and runs very faster. When I'm going to show you the demonstration, you will appreciate how quickly those are. So that's what the containers are all about. What is this container? What is this Docker? If we take a quick step back and try to understand what really Docker is all about. Docker, when we say Docker, there are 2 things. Docker Inc. is the company which came out with Docker. And we also have Docker as a technology, as a software, which provides you the platform for getting the code on your laptop into the cloud in a very, very easy way. It helps you assemble your applications and all of its components and deploy and run those applications inside your container. Docker as a software helps you do all of that. A little bit of history of how Docker came into play and how these containers are getting popular. So even before Docker made containers popular, way in early 2013-14, there existed technology in your Linux kernel. Various different contributors have contributed towards the Linux kernel development out there. There was Google, which was making use of containers even before Docker made containers popular, and they contributed a lot to the kernel-related technologies around Docker, like a component called as C group. There was Red Hat, which gave us namespaces. There was IBM, which gave us in 2007-8 a library called as 𝐿𝐿𝐿. There existed these features in your Linux kernel. So now when I told you it gives you that isolation at the operating system level, it creates a box in which you can drop your application. But how does that happen? How does that happen? Is there are different kernel technologies. To name a few, we're not going to go deep dive into those, but we should know what's going on and how does it work. Is there are few technologies which you can Google if you want to, called as Linux namespaces, C groups, capabilities, union file system, chroot. To name a few, these were the few Linux kernel features what Docker made use of. And what happened is, the history behind this is Docker Inc., before it was called as Docker Inc., it was called as .cloud. The job of them, that company .cloud, what they did, they was platform as a service provider, and whatever service they were offering, they were running and deploying that on those Linux containers. That was kind of a secret sauce. Only the people, not many people knew, and few organizations like Google have been using it for quite some time, like Red Hat and IBM and all of them. This .cloud was also making use of them to manage these kernel features and talk to the 𝐿𝐿𝐿 and get those building blocks and create those isolation, create those boxes, which would then give you that separate isolation, give you a separate host name, an IP address, file system. What Docker did, they came out with their own tool. Sorry, what .cloud did. And they nicknamed this tool as Docker. Docker as an English word, it's dock worker, as in somebody who loads and unloads your ships, your cargo ships. Dock worker, two words combined together and then made it as Docker. And Docker realized the popularity of this, the convenience of this, and they gave you a simple CLI tool, making use of which you can talk to the underlying kernel features and create these facets of isolation and create those containers with simple commands. Docker realized what they were doing, inventing, and that's how the technology was born. They renamed themselves from .cloud. From .cloud, they renamed themselves to Docker Inc. And they got rid of their platform as a service side of the business, and they focused on bringing containers to the mainstream IT. And if you really look at it, they've been immensely popular and immensely successful in doing so. There's a popular blog out there. I'm sorry, I forgot to put that on the slide. And if you just go look at Docker in numbers, in the Q2 of last year alone, and so far from the time Docker has been around, Docker has a centralized place called as Docker Hub, where it places all of its images. What images are, we will talk about that in a minute though. There are more than 300 and it's close to 400 odd billion downloads. B for billion, that's the number of downloads of these images happened so far. In the Q2 of last year alone, we had close to 50 billion pulls. We have more than 12 million user accounts and more than 9 million repositories out there on the Docker app. That talks about the popularity, and Docker has been immensely popular and successful in bringing the main containers into mainstream IT. That is where we are here right now, trying to understand what this Docker is all about. Let's go take a look at the architecture. I understand the time what I've been given is a little less. So we will look at an architecture from the 10,000 feet view. All right. Docker, it makes use of the client server architecture. The client and the server, the simplest of the setup is where both of them running on the same machine. You have the client, you have the server, both of them running on your same machine. Server, we call it as Docker daemon, Docker engine, Docker host, Docker itself, all of them means the same, which runs as a system service on your machine, is the one which is responsible for building your images, creating your containers, starting and managing your containers, creating your volumes, pushing and pulling your images. All of the hard work is taken care by your Docker daemon. Whereas client is a CLI, which lets you talk to your Docker daemon. Docker daemon exposes an REST API to which when you run your Docker commands like Docker create me a container, Docker build me an image, it's going to convert those commands into the REST APIs and talk to your Docker daemon behind the scene. Simplest to set up is both of them running together. But having said that, it's a client server architecture. You can have the client installed on your laptop and you have your data center somewhere in New York, we have your Docker host running there. That also works. From a remote client, you can talk to your remote Docker host and execute those commands. When you do so, it's the Docker engine, the Docker daemon, the Docker host is the one which is doing a lot of hard work. Traditionally, earlier, Docker daemon used to be a monolith library. They kind of broke it down. So you might have heard terms like container D, run C. Those are all the subcomponents of Docker daemon. Are we going to talk about that? No, time is not permitting, but that's how it's been modular and it's broken down. Long story short, you have client and your server. Client is the one which gives you the CLI. Our server is the one which does the hard work of creating and running your containers. Moving on from here, what are these images? To create and run our container, we need something called as an image. What is that? All right. So now, when we forget the containers for 2 minutes and we come back to our server. All right. So I have a server of mine, and then I'm from the operations team, and you are from the development team. Say you want me to deploy the application. So what will you tell me? You will give me a playbook or a document which tells me what I need to do. Right? Just taking that source code and dumping it on the server, my application is not going to run. I have to create an environment. For example, if I have a blank empty server and you give me an activity guide, you'll give me an operation manual that tells you how do I set up the application. For example, I'm from the testing team. So I have to follow those instructions. You'll say, hey, listen, all of these applications, what we deploy in our organizations are all based on Ubuntu 20 maybe. So I need to procure a Ubuntu 20 server. Good. Then just downloading the source code from the GitHub won't work. I need to download the source code, and that source code is all built on maybe Java. I need to install the Java or Python or Golang, whatever I have. The source code, what I have downloaded, I have to compile and convert it in an executable format. And then if I need some variables, some config data, I have to make an environment on the server. And then when I run that application, the executable, that's when the application runs on my server, right? So first you had to write your project, and then you had to set up the environment where your application could run. This is where things would go wrong traditionally, where when I gave you those instructions of how to set things up, I might have taken few things for granted because I already had some binaries and libraries on my machine, which I had installed maybe while I was working on some previous project. And I took it for granted, and I assumed those binaries or those libraries or those variables are going to be available on your server. You followed the instructions what I gave you, and you deployed and ran. Things don't work the way you expected. And when you come back and complain to me, I'll say, hey, listen, it is working absolutely fine in my laptop. Then you say, come back and look at here, it's not working fine. This is one classical problem of it works on my machine, which I'm sure every developer can vouch for it. You would have definitely faced in your life any one time. The project might not work at the same optimization or maybe same level of working even. Maybe few links gets broken out there, but it works absolutely fine on your machine. Right? That's a very nasty problem we have that it works on my machine. And when you go look at your staging servers, your productions where you deploy your applications, things don't work the way you anticipated. The reason for that is you're missing few things. While setting up your environment, while you passing out the instructions, you took maybe few things for granted and things break. How does that problem get solved here is when you want to run an application inside the container, you got to give it in the format what the container understands. Like when you wanted to run that application on your server, you had to convert that into object code. You could just not drop that code there. It did not run there. You had to convert it in the format what your server needed. And so what did you do is you convert it in that format. Similar, when you want to run that as part of your container, you have to give it in a format which the container understands. And for that, you have to write something called as Dockerfile, the step-by-step instructions, what you would assemble at the command line to create an image. Image, keeping it short, is like a template. If you're from the virtual machine world, you can think of image similar to a VM template, like a stopped virtual machine, making use of which you can spin out multiple virtual machines. Image is similar. Image of a container is what the image contains everything what the application needs. Because making use of this image, when you create a container, that container needs an isolated file system. That container is running on my server. The server also has a file system. When I create a container, that container gets another file system, an isolated file system. And where is that coming from? That is coming from the image. And my application can't see anything outside the container. It's going to look at everything inside the file system. So whatever my application needs, everything needs to be part of the image. So when you build your application image, you will ensure all of the dependencies, the binaries, the configs, the environment variables, the metadata, whatever is needed for my application to run is part of the image. And then making use of the image, you can create and run a container. To create a container, you need to have an image, the different ways of getting the images, and these images are published and made available on a lot of registries. Docker Hub is one such registry. Centralized place where you have a lot of publicly available images. You can also have your private images, just like you have your GitHub, where you have your repositories, where you put in your code, which can be used by public or private. You can do the same thing. Long story short, image acts as the build time, container acts as the runtime. Making use of the image is what I have my container. This image has everything what my application needs. But how is this going to solve the problem of it works on my machine? Good question. The way it's going to solve is when you build this image, when you write a Docker file, a step-by-step instruction which assembles, which tells you what needs to be there part of the image. Just like when you're making a dish, you write down the steps. And if I'm making a cake, I say, take a bowl, add some water, add some sugar. I write down a recipe. I'm going to look at that, execute those steps, I get that cake made. Similar, when I'm trying to build my image, I will have something called a Docker file, which is like a script, where I write all of those instructions. And when I make use of commands like Docker image build, where it's going to build that image for me, it's going to execute all of those commands and it's going to stack all of them together. Images are immutable. They are read-only in nature. The only possible physical operation what you can do after you build the image is delete them. You can't modify them. That's the advantage. They're immutable. So if I've built the image and I have that image with me to create a container, and only thing what I need is a machine which has Docker installed if I have the application image to spin up that application and run. So traditionally, I had to give you a playbook. You had to execute all of those on the server, set up that server for yourself before you could deploy and run that application. Now, all I need to do is give you the image. The way that container was running in my computer, when you have the image, when you download the image and create a container out of that, it is going to behave the same way. If it works on my machine, it's going to work on your machine. If it does not work here, it's not going to work there as well. These images will be immutable in nature. You can't modify them. And that's how it tackles the problem of it works on my machine, the classical problem, what we were talking about. Right? That's your image. It's a couple of commands to create your containers and then run your containers. Let's go take a look at a little bit of demonstration. All right. Let's deploy a container. We can deploy some game. We'll do both. We'll deploy a Jenkins as an application. We'll deploy an application or some game or some sort of application out there, which I will let you access as well. All right. So what do we need? What do we need to do a demonstration? Well, you need to have a server. What kind? Linux, Windows, both of them works. But I was the one who told you that it makes use of what? Linux as the Linux kernel features. That's the true story. When it started off, it started making use of the Linux kernel features. When the Docker started getting containers started become popular, 2014, 13 and 14, Microsoft also realized the benefit of Docker. And what did they do? They partnered with Docker. A group of engineers from Microsoft and Docker were working together to develop an alternate technology which can work on Windows as well. So as a cross-platform portability, now Docker also works on Windows as well. So you can set up Docker on Windows or Docker on Linux. All works fine. But the only concern is if you're running Windows workload, you need to have Windows as the runtime what installed on that Windows operating system. On Linux, you need Linux. I spoke to you about few kernel technologies like namespaces, capabilities, layer capabilities, or C groups. Windows also have the equivalent technologies built out. We have process tables there. We have WICFS there and stuff like that, which allows you to create and run containers on Windows as well. So for this demonstration, I'm going to make use of a Linux server. What I have a Linux server right now. I have Docker installed on it. The question is, how easy or how difficult is it to install Docker? It is very, very, very simple. Let me quickly show you how to set up Docker as well. If I quickly show you that, if I just go to my Google and I ask for, I want Docker. If I just say get Docker, it takes me to the Docker documentation and tells you what you want to do. Docker engine is what I want. If I choose the engine here and I say install, it tells you what kind of operating system. Any operating system which has a kernel version of 3.10. When I say any operating system, I mean any Linux distribution. You see on the left-hand side, we have various different distributions listed here based on whatever distribution you have. You can click on that. Long story short, all of your distributions are similar. When I say similar, the Linux kernel is same on all of them. The softwares on top of them make them different, right? So, like for example, CentOS has a package manager called as Yum. Maybe SUSE has Zipper. Maybe Debian has apt. You click on them, it takes you and tells you, what are those commands. You don't need to remember all of them. All you need to do is copy paste from here. It's going to set up that repository, and it's going to give you those commands based on your operating system to install. As simple as this. But it is even much simpler. I don't even want to look at any of those. All I have is a convenient script down here. I have a machine which has the software requirements what I'm meeting. All I need to do is download this script and run this script, sh, and run this script. It's going to take care of setting up those repositories, installing those packages for you, making it very, very simple for us. That's what I did as well before we could come here. And this is where I have Docker installed on my machine right now. All right. So now to run a container, first and foremost thing is I need an image of that particular application. You need to have those images available on your machine locally. That's when you can create a container. But right now, I don't have any. That's okay. That's not a problem. Why? Because we have a centralized place called as Docker Hub. There are many such centralized registries. JFrog Artifactory, we have GitHub Container Registry, GCR, ECR, many of them out there. From Docker point of view, Docker Hub is that centralized registry what we have, where we have lots of images, millions of images available for you, publicly facing. Of course, you can also have your private. For example, I want to make use of Jenkins as an example for this demonstration. There's an image, official image of Jenkins available, using which I could create a container. But before I go there, let's take a look at how can I install Jenkins. We all know it's a very popular CI/CD server out there. If I do Jenkins.io, for example, it tells me what I need to do. This is the Jenkins, and if I go to docs of the Jenkins, and if I say I want to install Jenkins, say for example, I want to install it on my Windows. It tells you a few things. Listen, hold on. Before you can download and do all of that, you have some minimum Java requirement. So you need to, on the server where you're installing, you need to have JR11 or 17 or any of those. Maybe you need to have some browser compatibility. You need to have some Windows support compatibility. So before I could really deploy Jenkins as a service, not Jenkins as a binary, as a software, and start installing and making use of that on my machine, I need to ensure the dependence is what this application needs. In short, I need to ensure the environment what that application needs is made available. Just downloading this binary and running that binary is not going to help. I need to have that supporting role, the Java, the compatibilities, the packages installed. Then I can download this and run, and I can set it up. Maybe on tops, it takes me half an hour to do so. All right. The same Jenkins image is available for me on Docker Hub. So what they've done is if compiled and bundled everything as an image. In that image, everything what the Jenkins need is available. That whichever version of Java it needs, whichever browser, operating system compatibility binaries they need, they have updated and they have made an image for me. And all I need to do is download this image and create a container out of that. And I have my Jenkins up and running. I have copied this image right now with me. Let me go ahead and deploy that. So what we're doing is making use of an image of Jenkins and creating and running a container. Don't worry about these commands. There's some options I'm specifying, some port numbers. You will get that. The only point what you want to understand is I'm creating a container. To create a container, I need to have an image and specifying the image, and that image needs to be available locally on your machine. That image is not available on my machine. Not to worry, that image is publicly available for me on Docker Hub, and my Docker daemon is designed to go fetch that image. Now, all it took me is less than 30 seconds, and that image got downloaded, and that application got run and got created as a container on my machine. All right. It is available for me. I've exposed a port. It's available for me on this port number. So if I quickly look at what my public IP is, curl if config.io, or if I go to my portal, it gives me the IP. If I take this and then go back and look at the port number, what we gave was 8080. What do we see? We are now able to access the Jenkins application out there, which is running inside the container. Traditionally, if you had downloaded a Jenkins as binary, might have taken you half an hour for you to install your Java, your compatibilities, your tools, and all of that. What really happened, the magic here, this image which somebody built and made it available for me, had everything what the Jenkins needed. All I had to do, download that image, spin out a container from that. And in a matter of few seconds, I have my application up and running. That's the advantage. That's the benefit, because traditionally, when you gave me a list of set of commands for me to assemble the application and start testing, I would waste my time setting up the environment. Now, what do you give is you give me the image, and all I need to have to start testing and working on that application is Docker install. All I need to do, download the image, spin out a container from that image. That's exactly what we did. We see Jenkins is up and running. It's asking me to unlock. It's telling me for you to enter some initial password. Fine, let's do that. That initial password is available for me at some specific place. War Docker. I was typing it wrong. It's secrets. Inside the secrets, we have a folder. We have a file called as initial admin password. All right, let me take a look at that real quick. And what I have is an initial admin password. I'm going to make use of this. And voila, this is how my Jenkins is up and running. For argument sake, for in the interest of time, I will choose none of the plugins to be installed. And I do not want to create any admin users as well. I'll continue as what I have and start making use of Jenkins. There you see, I have my application up and running. Jenkins is available for me on my browser in a matter of a minute. I can do whatever I want. I can maybe, go to manage Jenkins and add some plugins if I want to, or if I just go to new item and create a new job. So I'll just create a demo job. There's only one plugin I have. You can't see a pipeline because I've not installed the plugin. We understand that. That's just some dummy job is what I'm going to create. Something that executes a shell like ls maybe. Just to show you that we've created a job. We configured, installed the plugins, and I did not install any plugins per se in the interest of time. But the point I wanted to make was it is so easy. You realize now that setting up and running those jobs. It took me less than a minute to download that image and spin out and run my application out there. And if you have the application image available on your machine, it's not even going to take that much time as well. You can further, if you have the image available locally, it just takes less than a second to spin out a container, and that's the time, that's the productivity what you get. Instead of you setting up the environment and running that application, you have the image, spin that out in a container, and the application runs real fine. That was a little bit of demonstration when it comes to the container. All right, going back to our slides, let's go back and take a look at that. What I tried to show you is the benefit of a container where I could run an application inside that. I did not have to install Java on my server, nor whatever the compatibilities what Jenkins needed. All was bundled as an image. Download the image, spin out that application. Took me less than like 30 seconds flat to run that application. That's the benefit of containers. Like we said, that isolation what it gives you, it lets you run a lot of applications out there and gives you productivity like the way we saw right now, and has many different features. Time is a crux for me to talk about the features in great deal. Well, I'm hoping we have a fair understanding of what containers are all about right now. So next important question is, what is this Kubernetes? Whenever we hear containers and Dockers and stuff like that, we also hear the term Kubernetes as well. And we kind of know it's an application orchestrator. What do I mean by that? The most common and most popular uh, the description of Kubernetes, what you will find anywhere you go, is Kubernetes is an application orchestrator for your containerized application. What those these jargons means? Why do I really need an orchestration tool? For we to understand that, let's take a quick step back. Now, we have understood the benefits of container, that microservices. I have broken it down. I have deployed it as, let's say, the whole monolith application I had. I've broken it down and deployed it on my server. On my server as small containers of each. 20 microservices is what we broke it down to. 20 containers is what I am running. All of them are running on a single host I have right now. Right? And I've exposed those containers to the outside world, and end users are accessing the application just like the way we saw our Jenkins right now. Right? If I share the URL with you, you will also be able to access the same application because I've exposed it to the outside world. Life is good. People are accessing my containers. The applications are running inside them. And what happens if my server goes down? It's going to be single point of failure, SPOF. All of my containers are running on the same server, on a single server, and that server crashes. So what happens? All of my containers are going to crash along with that. What do? We will set up multiple servers. Instead of having one server, I will make use of 3 or 4 different servers where I can deploy and run my containers on. If one fails, I still have the option of going to the second and third server and taking care of them. Or I can run replicas, copies of the same application on all of those servers. If one of them fail, other can take over. That's how traditionally we deploy applications as well, right? We have our application servers. We don't run a standalone application server. We have a bunch of application servers. We put them behind a load balancer, and end user is going to access the load balancer. Based on the load balancer logic is how I'll be routed to any one of the application server. Same story when it comes to containers as well. Each container is having its own IP address, own host name. It's all running separately on different hosts. When I have only one machine, one server where I'm running all these containers, it's a single point of failure. To avoid that problem, I will set up multiple servers where I can deploy multiple replicas of the application. That adds another layer of complexity. What do I mean by that? I have to take the decision of scheduling. So if I come back, earlier I had only one server. If I wanted to deploy an application, I went and deployed that. Fine. Now I have 4 servers to choose from. So if you ask me right now, go deploy the application on that server, which server do I go? Just making use of 4 or 5 servers for simplicity's sake. If we had 10 servers, if I had 100 servers where we are running Docker out there and we are running large scale applications and we have a lot of containers to be run, where do I schedule them? Should I go and deploy this on a server 1? Should I go deploy this on a server 2? How do I choose? Well, you have to make that scheduling decision based on what? Based on whatever criteria you have. Maybe you will set up some monitoring, set up some metric tool, which kind of gives you some information like, what is the memory, disk, and CPU pressure on the servers. Based on that, you will maybe manually decide where to go. So that task of scheduling is your headache. The task of monitoring and looking and keeping an eye on those containers is your problem. And if things break, server 1 was running 40 containers. That server 1 crashed along with whatever the reason, network partition, OS corruption, whatever the reason is. We have lost those 40 containers out there. Well, the good thing is I have a couple of other healthy servers there. I can deploy it there. So now I'm tasked with going ahead and deploying whatever was running on server 1 on 2, 3, and 4, and 5 different servers I have. But for me to do that, I should know how those containers were running in the first place on the server 1. So I need to have some config database or some spreadsheet maybe where I know how those containers were running. What image were they making use of? What ports they were making exposed? What volumes they were making use of? Many different options. So now what do I need? I have an additional job of storing those configurations as well. But every time I try to decide to deploy this container, I go make an entry in my spreadsheet telling that this is how my container was deployed. In the case where I want to heal, when I want to fix when things break, I can go refer this spreadsheet and come back and deploy. I'm just counting few problems. We had to look at the manual scheduling. We need to look at the manual way of monitoring and keeping an eye on these applications. We have a manual way of writing your configurations and many other problems, like, for example, manual way of performing a rollouts and rollbacks when you want to deploy the application. What other options do I have if I don't do it manually? Well, if you're intelligent, you can write your own scripts, some scripts, or make use of some third-party tools to monitor, which kind of feed some metrics there. You look at that data and you decide where to schedule, how to watch. You can do all of that. Or you can hire some engineers whose job is to keep an eye on these containers, keep an eye on these servers, and help you take these decisions and keep your application up and running out there without the end user having any issues. Both of them are going to cost you time and money. The easier option of that is the combination of this is there are many tools written to help you schedule, monitor, look at these config, self-heal, auto-scale, and perform zero downtime rollouts and rollbacks. There are many tools available in the market for that. And those tools are nothing but the orchestration tools. And Kubernetes is the de facto orchestration tool for our containers. Why do I say so? There are many container orchestration tools out there. Why only Kubernetes? Why not something else? Well, Kubernetes is the default orchestrator right now in the world. In the earlier days of 2013 and 15, there was a race. Docker also has a native orchestration tool called as Docker Swarm. We had Apache Mesos. We had Kubernetes from Google. Well, long story short, Google won the race hands down. The only reason, while I was discussing about containers, I told you about how Google has been one of the major contributors towards the Linux kernel technologies. They have been using, Google has been using containers at massive scale, like Gmail and your search, Google search, were all applications running behind the scene on Google's containers. And Google and its Kubernetes is a product from Google. Well, a little bit of story around that just to make it a little exciting. I know I am keeping an eye on time as well. When 2013-14, when AWS started making the modern day cloud computing very popular out there, all the other companies which had their own good clouds as well were trying to catch up to AWS. And Google is one such company. They also had a very good they also have a very good cloud platform out there, GCP, right? And they needed a way to get people towards their cloud. And what they did is they had their boatload of experience of running containers at scale. They were running containers even before Docker made containers popular. And the scale what we're talking about right now, I'm going to take you to the documentation and show you that. It's billion containers per week, before billion, right? That's the scale in which Google was running your containers. And to manage all of these containers, they had some couple of in-house proprietary tools called as Borg and Omega. When AWS was taking away all of the limelight, Google said, hey, we got to do something about it. It's a very good article or documentary on YouTube. If you can maybe take a look at that, like how did Kubernetes come into play? The Kubernetes documentary is what it's called as. It's very exciting. You should take a look at that. And they sat together, brainstormed. They said, listen, we are good at this and containers are popular. Why don't we make this open source and let Kubernetes out there? It's another way of getting the customers towards your Google Cloud. That's where Kubernetes was born. Lesson learned from tools called as Borg and Omega were converted into Kubernetes, and it was a CNCF, a Cloud Native Computing Foundation, was created, and Kubernetes was made as an open source project out there. From that time onwards, Kubernetes has been the leader. It's been one of the most popular cloud technology, cloud platform out there. The only reason is it is a proven technology to scale and run at the extreme large scales of billions of containers without you having to scale up your operations team. Of course, I said it's a tool from Google, but that's not the point. The point is it's a proven technology, a proven orchestrator. It is composable, it is open source, it's pluggable, it's hookable. You can take it, you can create your own custom resources modify, and manage it. If you now go back and look at Kubernetes as such, if you look at any different versions of Kubernetes, what we have hosted solutions as well, right? Like you have your EKS, EKS, GKE, and all of them, and you have Rancher from SUSE, you have OpenShift from Red Hat. All of them run your Kubernetes under the hood to orchestrate your containers. That's the popularity of Docker. Sorry, that's Kubernetes. Swarm is lost out on the race. Somewhere around 2.5% is what the Swarm is, and that's where we are here trying to learn Kubernetes because that's the leader and that's the de facto orchestration tool of choice for the enterprises. The reason has billions of contributors, sorry, millions of contributors, millions of all of your large or popular companies are major contributors to this Kubernetes project. It's open source, maintained by a foundation called as CNCF. You can take this, download it, run it without any cost. You can set up your own clusters, you can create your own custom resources, you can manage and deploy your applications on there. That's what that Kubernetes allows you. Kubernetes is a cluster. When I say cluster, just like a cluster in a computer science world, we have more than one or two servers working towards for a common cause. Kubernetes works as a cluster where you have standalone hosts. What we had, 4 or 5 of those machines, we join them together. Just like in any cluster, you have one of the machine acting as the control plane, the manager. The only job of that guy is to manage and run your worker nodes, manage your cluster. And the worker nodes are the ones which run your workloads. Worker nodes are the ones which have your container runtime. Worker nodes are the one which have your Docker installed on them, which is going to create, download, and run those container images. Kubernetes and Docker go hand in hand. Complementary technologies. Docker, say for example, if I have a 10-node cluster and all of those 10 nodes, I'll have Docker as a container runtime installed, which is going to download those images, create those containers for me. And Kubernetes is going to be a technology which is going to sit on top, which is going to orchestrate and manage it, where to deploy, where to schedule, if it is running or not, keep an eye on it, monitor it, all of that. High-level technology is taken care, high-level job is taken care by Kubernetes, and running and creating your applications is still taken care by some container runtime. I'm making use of an example called as Docker. There are other popular container runtimes as well, like Containerd or CRI-O, which can work on those worker nodes, and Kubernetes can work along with them as well. Let's look at few building blocks. I'm quickly checking with Shivan. Shivan, how much time do I have, dear? All right, looks like I'm hoping I have some more time. Let's look at few building blocks. Kubernetes gives you a set of building blocks which allows you to deploy your applications, maintain and run them, and scale them. You can edit and introspect and watch your applications. You can change them. You can roll out them. It gives you a lot of benefits of managing and running your applications. It gives you the way when you want to run and deploy your applications, most common use cases of discovery, of name discovery, of monitoring, logging. It gives you the role-based access control, the authentication and authorization. It gives you many such features, and more importantly, it lets you allow to run at a very large scale. That's where Kubernetes is very popular.
I'm really sorry, sir. My mic was not able to unmute. Sir,
No problem.
we've got a little. We're quite crunched up on the time.
Give me a number. Give me a number.
I'd say around 10 more minutes.
All right. Thank you.
15 more minutes, I'd say.
Done. I need to show them a deployment. Thank you. Not much. Thank you, Shivan. All right. So there are many popular versions of Kubernetes. What we have a self-managed cluster where me and you can download these binaries out there and set up our own cluster where we are in control. We set up the control plane, we add the worker nodes, we deploy applications on them. And all of your major cloud providers are offering Kubernetes as a service as well. Like Azure has AKS and AWS has EKS and stuff like that, where you don't worry about setting up the cluster. You pay some dollars, you get that service. You can start deploying your containers on those cluster. Managing, maintaining, securing, upkeep, all of those control planes is all taken care by your cloud provider. They are hosted solutions, which are important and which are quite popular as well. What we will look at is the self-managed. So for you to be called as a Kubernetes administrator, you should know how to manage a cluster on your own. A self-managed cluster is what you should have. You should know. CKA is one of the exam which tests your knowledge around that. If you look at it in a way, like self-managing a cluster is like driving your manual car, where you shift your gears and you control what speed and what throttle you have. Whereas maybe a hosted solution is like driving an automatic car. You put it to drive and you keep accelerating. Something similar. So if you know how to do the hard way, driving the easier way is easy. Having said that, that's where we look at the self-managed Kubernetes cluster. Just talking about little concept of the architecture of the Kubernetes. It's a cluster. When I say cluster, one or two or more machines working together. In every cluster in computer science, you have some nodes which behave like managers, or control plane is what we call them, and we have worker nodes. Job of control planes is to provide you the control over your worker nodes. They allocate the task to worker nodes. They keep an eye on the worker nodes. They keep an eye on the workload. They take care of the decisions of scheduling, monitoring, and storing your configuration. That's the job of your control plane. Whereas the job of your worker node is to run those workloads. Whatever container I wanted you to run, the worker nodes will run those workloads. And there are components in the workload which kind of keep on updating my control plane about what the current status is all about. And that information is continuously stored in my control plane's database. Time is a luxury right now. I can't go in depth of the architecture though. But long story, this is how few components of my Kubernetes is going to look like. The control plane is going to have a scheduler, an API server to which everybody is going to talk to, a data store, which is going to store my entire configuration, a controller manager, which is going to spin a lot of independent control loops and keep an eye on my cluster and respond to events and changes. And because of this controller is why the superpower Kubernetes can do whatever it does, like self-healing, scaling, and stuff like that. Few building blocks. I'm going to talk a little bit about that. When it comes to Kubernetes world, if you need to deploy an application in Kubernetes, you do so by putting them inside a pod. What is it? Something new? It's not new. It's the same thing. Pods augment your container. They add value to your container. So pod is nothing but a group of containers. Like you have pod of whales or pod of peas, a group of them together. In the Kubernetes world, when you say we want to deploy and run your application on a Kubernetes cluster, you do so by putting it inside a pod. From visualization point of view, pod is just another wrapper on your container. The way you build your applications when you wanted to run your container in the standalone mode still remains the same. But when you want to deploy and Kubernetes to take care of managing them, you wrap it up in a pod. Pod is just another way you wrap your container on. Do not have the luxury to get into the technicality of that. The basic common unit when it comes to virtualization was a virtual machine. In container, in Docker world, it was container. In the Kubernetes world, the most atomic unit of computing what you can deploy is pod. What do I mean by that? Deploying and running an application on Kubernetes world, meaning you're putting that inside a pod. Stopping an application is stopping that pod. Scaling that application is increasing the number of pods. That is what I mean. So when you want to run your application on Kubernetes cluster, you do so by putting that inside a pod. Technically, we will get to that. A pod is a shared execution environment for one or more containers. So you can have one containers, you can have multiple containers inside a pod. From visualization point of view, little bigger than your image. Sorry, little bigger than your container. Why do we need that? Well, there are application use cases where I have a couple of microservices which needs to be co-located, co-scheduled for them to work fine. Scenarios like that, you can put one or more containers, maximum up to 6, inside a container. Those are called as multi-container pods, but most common use case is a single container per pod is what we will look at. I'm going to skip through this a little bit for the interest of time. So when you want to scale up, what we do is you put and scale up multiple pods. When you want to have more replicas of your application, you do so by putting them in different pods and not adding all the containers in the same pod as well. All right, which you really can't, and that's what we're trying to tell you. When I have multiple replicas of my pod, to access that pod, I need a load balancer. Every pod is going to have its own IP. So how do I configure my end user access to? We make use of a concept called a service, which is going to provide us a load balancing feature, using which I can service when I create as an object gives me a stable IP address, a stable DNS name, and a stable port, which I can take and configure my end user access. Behind the scene, it is going to load balance across multiple pods what we have. That's what your service is all about. There are different type of services. One type of services which allows you to make that service available inside your cluster, that is cluster IP, where you can expose that and make it outside, available to the outside world by calling it as node port. And if you're running a hosted cloud solution, a hosted Kubernetes solution, you can also make use of a load balancer type of service to deploy them. Couple of options. I will show you that when we go look at the demonstration. So when I deploy a pod out there, and it gets scheduled and goes on some worker node and runs there, it runs absolutely fine. But the superpower of my Kubernetes is Kubernetes provides me self-healing. What do I mean by self-healing? Things break, I don't have to get involved. It'll automatically fix itself. But hey, how is it going to do? Well, for it to automatically work, you need to tell how it needs to work. That's where your design pattern and declarative pattern comes into picture. So when you deploy an application, you deploy it with a desired state. You say, this is how I want my application to look like. When you do so, that's where your controllers kick in, and their job is to look at what is your desired state and go observe what is your current state in your cluster. Your desired state versus the current state of cluster. It's going to go determine the differences. If there are any differences, it is going to reconcile. For that to work, for this feature to kick in, the self-healing to work, for rollouts to happen, the zero downtime rollouts and rollbacks to happen, we need somebody to do that for us. Just deploying a pod on the Kubernetes cluster is going to get my application running out there, but it is not going to give me any superpower of Kubernetes. For me to achieve that, I deploy them making use of a controller, a wrapper on top of a pod, a controller which gives me this grip, this gives me the feature where it's going to keep an eye on what my desired state is. For right now, when I create a deployment, I tell, hey, my desired state is I need 3 pods at any given point of time. The job of this deployment controller is to go look at the cluster and ensure there are 3 pods always running. So now node 1 knocks out. Along with that, 2 of my pods die. So what happened? My desired state was 3, but my current state is 1 right now. This deployment controller is keeping an eye on it. And it said, nope, user wanted 3, I have 1. What do I need to do? To get to the desired state of the user, I need to deploy 2 more pods. And it's going to automatically look at the desired state, what you had given, which is stored in your database, in your config database. It's going to read that and it's going to go talk to your API server and get 2 more pods created for you. In a way, what did it do? It was self-healing without you having to get involved. 2 o'clock in the night when the node crashed, the replicas went down, you don't have to log in and do anything. Kubernetes will take care of that for you. You change your desired state. My desired state is 3 right now. I change it to 6. Well, why do I have replicas? I have replicas because I have load and I want to distribute that load. And currently, I had 3 copies and I said, no, that's enough to handle the load. I'm realizing a lot of load coming in my way and I want to change my desired state of the running application. I can do so. And when I do so from 3 and I say the desired state I have right now is 6. When I do so, what am I doing? I'm scaling out. I'm scaling up. Similarly, I can just reduce my desired state. I can scale down as well. Controllers, different controllers we have in Kubernetes gives you this option. Deployment is one such popular controller what you'll make use of, which offers you self-healing, scalability, and offers you features for performing zero downtime, rolling updates, and rollbacks. There are many controllers like daemon set, stateful set, HPA. Each controller provides you a different feature. For example, we have HPA, which provides you the feature of auto scaling. You configure it of how my application should look like. Based on the incoming load, the replicas will be scaled up automatically. There's another controller called as HPA, which does that. You create a deployment and you create a HPA on top of it and hand over the scaling part to the HPA and you set some criteria. Hey, when the load goes up above 80%, I want you to add this replicas. It's going to scale up. When the load comes down below 80%, this is the number of count I'm looking at. So it's going to scale down. It's going to automatically scale up and scale down. It's going to happen with the help of a controller called as HPA. Right? There are many different controllers this way. Just trying to introduce you to a few of the components. So the question is, who should learn Kubernetes? Or let me show you why you should learn Kubernetes. This is the reason why you should learn Kubernetes. The source what we have got this slide from is from Stack Overflow. Everybody knows what Stack Overflow, right? If that goes down, we can't do our coding. I know that. Right. So most popular and most loved technology out there, when we looked at the Stack Overflow survey, Docker is at number 2. I don't know why that's missing here. And sorry, Docker is at number 1. Number 2, what you have right at the top is Kubernetes. It's a very, very popular technology. Containers are going to be there everywhere. And Docker is the one which is making it popular. And Kubernetes is the tool which is going to orchestrate and manage those containers. So I'm sure you already are exposed to containers. You're all exposed to Docker and Kubernetes. If not, you will definitely be exposed to these in the near future. It is the most loved technology on the planet. Right at the top there, Stack Overflow tells us that, the survey done from a lot of developers out there. And that's the reason you should look at it. Look at who needs to look at what kind of roles and responsibilities, what we need to look at. What I will do is I will pause here in the interest of time. I will demonstrate a real quick application deployment out there. Right? I will leave this to Shivans to talk about. Let me just run a demonstration for you of how to run an application on Kubernetes cluster. So what I did, let me end this slideshow and go back to my server. I already have set up my cluster. I have 3 nodes out there. One machine acting as a master control plane for me. I have a couple of worker nodes set up for myself. The worker nodes is where my user workload is going to get deployed. And control plane is the one which is going to manage all of them. I have the cluster set up and up and running. I already have an image. Let's make use of an image to deploy a game. We're going to deploy a game. I can make use of commands like kubectl, create me a deployment. We will deploy a game right now. We could have also done the Jenkins just like the way we did. Let's take a game image from a user account, what I saw. And I want 5 copies of them deployed. A deployment got created right now. Don't worry about the command line. What I did was 5 copies of a game, of an application, of a containerized application is what I deployed. If I go back and say kubectl, show me those pods, we have 5 containers running out there on my Kubernetes cluster. Where are they running? Who took care of which node to run, what to run? Kubernetes took care of all of that. If I do -o wide, we see they spread across other nodes I have. Few of them went to my node 1, few of them went to my node 2. Every container, every pod has its own IP address. I have 5 replicas of them. How do I make my end user access this application? Well, good point. What I will do is I will expose it. I will create a service of a type node port, which is going to allow me to access this application. Kubectl expose is the option. Expose the deployment. The name of the deployment, what did I make use of, was game. And the port, what I want where the application is listening is port 80. The type of the service, what I want is node port. Don't worry about the commands. Kubectl get all. What I've done is I've deployed my application, right? And as a deployment controller. So I told you about self-healing. For example, I delete one of this guy, kubectl, delete this particular pod. Simulating a node went down, as in I lost my pod. My desired state was set to 5. What happened when it got deleted? The deployment controller was looking at it and it said, hey, hold on. User said 5, but I have 4 right now. What did it do? It recreated that automatically for me. What happened? Self-healed, right? My desired state is set to 5. I want to change it. Well, I can. I can scale manually. I can say kubectl, hey, I want to scale this deployment called as game. What I have, I had 5 replicas, I thought which was enough, but I have lots of people accessing it right now. Scale it up. I changed my desired state from 5 to 9. So what did the deployment controller do? Hey, there are only 5 pods out there. The user changed desired state. So it added 4 more pods for me. The self-healing, the manual scaling is what we saw. I can show you zero downtime rollouts and rollbacks. Interest of time, I can't. Well, that is how you deploy an application. I could also create an auto scaler on top of it, which is going to scale up and scale down automatically based on the workload. But anyway, I've exposed my application to the outside world. What I'm going to do real quick is I'm going to do curl if config.io, which is going to give me my public IP. I'm going to make use of my public IP. And what am I going to do? Make use of the port what I've exposed. And I'm going to access the game what I've deployed. If I share this URL, I don't know if I can share that with you or not. I don't know where to put that in the chat. Let me see if I can put that in the chat for you. I've shared that URL on the chat window. If you can access that, I think you should be able to. What you would be doing is accessing the game, which is right now running on my machine. It's a simple game, 2408 tile, where you can join those tiles and add the number and make it to 2048. It's a very popular game. Of course, not written by me. It has sourced it from somebody else, Gabriel. And what we've done is we've deployed this game inside a container, and it's running out there inside my container. I have multiple replicas of it, and I've exposed it to outside world. If hundreds of users start accessing this, I have 7 or 8, 9 replicas out there which are capable enough to serve the end users. If the load increases, I could have configured the auto scaler, which could have added more replicas, more containers, and I could have served the end users. What we did is just deploy this game. Very nice game, very addictive. You can add them and look at this. All right. And I've shared the URL with you. You can access it as well. Going back to the slide deck, that was my demonstration of running an application on Kubernetes cluster and showing you some popular features of Kubernetes like self-healing, scaling, and stuff around that. I will now hand over to my expert, our 𝐂𝐿𝐻, to take it forward from here. 𝐂𝐿𝐻, dear, thank you so much for your patience and your time. It's all yours. If you have any questions, I am open. Let me know. Thank you.
Thank you very much, sir. I'll just take the access. Okay. I hope my screen is visible, sir.
Yes, it is.
Okay, thank you very much. Guys, we are, like sir have mentioned countless times now, we are a little short on the timeline. So, sir, I would request you to answer the questions that are coming in the chat window that had already not been answered by our team. So you can directly answer them in the chat window. If there's a reoccurring question or anything like that, you can directly unmute yourself wherever you feel like, or at the end, we'll just pick up a few more questions that come up in the meantime. Okay?
Done.
Okay, thank you, sir. So, guys, till now, you have seen quite literally from the very basics what is.
Your voice is a little feeble, 𝐂𝐿𝐻. If you can be closer to the mic, it'll be great.
Okay, I'll just check my audio. There's some problem with my audio happening today. Is it better now?
Much better. I think you are a little closer away from your mic. No, you're good. Thank you.
Okay, thank you very much, sir. So, guys, till now, sir have taught you quite literally from the very basics about Docker, Kubernetes, and a lot of other things associated as well. Now, let's have a look at whether there is an actual demand in the market or not. Even though there was one particular kind of graph that sir showed that you can very well understand that Docker and Kubernetes right now are two of the very popular technologies out there in the market. But now let's have a look at the proper statistics as well as the numbers. Number one, there are thousands of companies that are currently using Kubernetes, from the likes of Google, Shopify, the New York Times, and so many more. You can just have a look at this list. Again, this is just the tip of the iceberg when I talk about it, because again, majority of the Fortune 500 companies today have adopted to use Docker and Kubernetes. Now, this is a graph till January of 2021, and you can see that there has been a steady uprise in the demand of Docker, of Kubernetes and containers job market, and it is on the rise till now, even if you look at it. Now, there are multiple amounts of jobs available for Kubernetes and Docker, irrespective of wherever you are located in the world, whether you are located in the United States of America or India or UK or any other country. When you look at the average salary package right now, it ranges between $50,000 to $142,557 a year. Again, it depends upon how much experience you have, how much projects that you have done, how much real implementation that you have done, along with the theoretical knowledge and the certifications on top of that. And currently in India, when you look at it, again, there are multiple amounts of jobs, thousands of jobs available. Whether when we look at the major metropolitan cities. Now, when we look at the containerization and Kubernetes trends, you will also see that, like I'm again and again mentioning that there has been a steady increase, but these are quite literally the numbers mentioned in the purest forms. Even if you'll see at the total market revenue in millions, currently it's 4,311 millions. And even if you'll see on the graph, you'll see that there has been a steady 30.8% of increase in the number. And currently there is a 69% Kubernetes, kind of containers in a way that a lot of different organizations are currently using Kubernetes. And out of the surveyed ones, 69% was using Kubernetes. Like, again, the average salary package is around $150,000 per annum. The top companies that are currently hiring are Accenture, JP Morgan, American Express, SAP, Cisco, and Mindtree. And I'm pretty damn sure that you would have heard the name of each and every one of these companies. Then there are 39,749 companies using Docker and Kubernetes, and this particular number continues to increase every single day. Now, what are the different Kubernetes certification out there in the market? First of all, this is the 𝐂𝐶𝐾 certification, which is Certified Kubernetes Administrator. When we look at the weightage of the particular certification and topics, then there are cluster architecture, installation, and configuration is 25%. Workloads and scheduling is 15%. Services and networking is 20%. Storage is 10%, and troubleshooting is 30%. So this is the particular topic breakdown. Like, for example, every certification exam would have different topics according to the different technology, and those different topics would have separate, separate weightage when it comes to how much importance does it have in that particular certification exam itself. Now, what is the, these are the few details. Number one, I'm sorry about that. Number one, the mode of the test, like how the test will be conducted, would be online. The duration would be around 2 hours. The certification validity is for 3 years. That means from the day that the certification is issued, the certification is valid for the next 3 years. After 3 years, you have to take the exam again and get certified again. The exam is based on performance and the exam fee. And when I talk about this exam fee, that means $395 you have to pay just to give the exam. That does not involve the training fee or any of the other things. Just a second, guys. Then is the exam overview for CKAD. That is the Certified Kubernetes Application Developer. The different domain-wise breakdown involves application design and build, that is 20%. Application deployment, that is 20%. Application observability and maintenance is 15%. Application environment configuration and security is 25%. Services and networking is 20% again. Sorry. Guys, again, if you guys have any doubts, any questions, please make sure you put them in the chat window directly. I've got an incredible team here as well. And currently, we have our trainer here as well in the chat, looking at all the questions that you have and answering them one by one. Okay, is my screen not visible, guys? I mean, it should be. Is my screen visible? Can somebody please confirm?
It is. Go ahead, Shivansh.
Okay, Manish, if you're not able to see my screen, or if anybody else is not able to see my screen, I would recommend you guys to leave the session and join in again. That would, pretty much solve the problem. Okay, moving on. So in this particular certification exam, guys, it's pretty much similar. The mode again is online. Duration is 2 hours. The certification validity is 3 years. The again, the exam is performance based, and the exam fee is $395. Now, there are three different actual certifications. First is Kubernetes Certified Kubernetes Administrator, then Certified Kubernetes Application Developer, and the last is Certified Kubernetes Security Specialist. Now, how the certification actually helps you? So, we looked at the job market trends. We looked at the available jobs as well, and now there is one more thing that we need to look at. That is how these certifications actually make a difference. Sir, could you please unmute yourself? I think there's some a little bit of a background noise coming up. Okay. So, guys, how do these certifications help you? That is a question that a lot of you guys would ask, because on top of that, you have to study for it, the theoretical knowledge and the practical knowledge. You do have to pay a hefty amount, that is $395. But how do these certifications actually help you in your career? Now, this is how. There are too many CVs out there. When we look at it from an HR's perspective, because of the job market how it is, there are a lot of people who are applying for these jobs. So that means an HR has tons and tons of CVs. Now, what that translate into is that an HR has around 15 seconds. That's actually a study that he or she has around 15 seconds of time to scan a CV and to then shortlist whether this candidate is worth giving a shot or not. And at that particular time, if your CV doesn't have a certification badge on it, that person or that HR would, obviously would not consider it, because the certification helps you give the credibility to the skills that you have mentioned in your in your CV. I have two different CVs in front of you. One is on left and one is on right. All the people who are watching this webinar right now, I want you guys to comment in the chat window, out of the two different CVs that have been put up in the slide right now, which one would you pick if you were an HR, or if you were an hiring manager or anything like that? Which one would you pick? Okay, everybody is saying right, and that is actually the right answer as well. So again, guys, this actually shows you how major of a difference it gives you. A lot of companies these days have actually put it up as a prerequisite itself as well. A lot of companies say that if you don't have a certification to your name, you cannot apply it to the company. So you understand how much importance the companies, even the companies directly are giving it, when it comes to certification. And a lot of, even after that, once you are certified, you whatever skills you have in that particular domain gets a very serious credibility, because again, these certifications are being organized, or these certification tests are being organized by the companies directly itself. It's not a third party company or anything like that. So that credibility is quite high when we talk about it. Okay, just a second, guys. Now, a lot of you, I believe a few of you guys have talked about how do you learn all of that. So this is the course, guys, that we offer on so we offer two different courses, one for CKA and one for CKAD. We have Docker and Certified Kubernetes Administrator, that is CKA. This particular course, we have 16 modules, 60 plus lessons, 34 hands-on labs, CV and exam preparation, quiz, and on-job support. I'm not gonna dwell too much into it. I'm just gonna give a quick overview of the things that are being offered. And if you are interested in it, please do mention it in the chat window. But along with that, please do make sure that you stay till the end, because there is one very important thing that I want you guys to look at before you go. And again, that one thing is also for absolutely for free. So guys, again, make sure you stay till the end. All the questions you guys are asking, please do put them down below. I see that my team is very well dedicated to answering all of the questions. So please do ask whatever questions you guys have, and whether it's an expert trainer or my team will definitely have a look at those questions and get them answered as soon as possible. Now, the learning path for Docker and Certified Kubernetes Administrator. So this is what I was talking about, the best possible way for you to actually learn it. This is one of the things that K21 Academy is the best at. So first of all, we start from the very first week where we talk about microservices and Docker. Then we move on. Again, guys, when you see majority of these weeks would have maybe a lab written on it or hands-on lab written on it, that means there is a proper dedicated hands-on labs. Whatever you're learning in theory, you have to practice that in practical as well. again, when we talk about the course that K21 offers, you obviously have those labs, both in the pre-recorded version where there is a proper video in which everything is shown one by one, and also there is uh, there is that other one as well where you directly get a chance to practice that yourself. So in week number 2 we cover Docker, networking, storage, and app stack. Then week 3 we cover Kubernetes architecture and installation. On week 4 we cover security, troubleshooting, and high availability. On week number 5 we cover networking. On week number 6 we cover deploying. On week number 7 we cover application stack. And on week number 8 we cover advanced networking. On week number 9th and 10th, we directly move on to the certification preparation, because by this time we are pretty sure that you have got the skills, both the technical knowledge as well as the theory, to go out there and get that certification done. So we have got two different certification practices as well. That means you have proper dedicated quizzes or certification test, if you want to call that, where you will get questions that are the questions that was previously asked in the different certification exam. So how this works is, so we have different batches of this particular course. Once the course is done, people go out to give the certification exams themselves, and once they are done with the certification exam, we ask them to come and tell us the feedback on the basis of what the questions were like, and on the basis of that we create these questions so that you can get a proper feel of what the questions are, the questions that are coming in the certification, what are they like. And that really helps you get a very kind of an in hand feel about what the certification questions or exam questions are like. So this is all about the CKA. Then there is the CKAD, that is Docker and Certified Kubernetes Application Developer. So in this, we have got 18 modules, 60 plus lessons, 34 hands-on labs, CV and exam preparation, quizzes, and again, on-job support. On-job support, again, is something that was offered before as well. And in this as well, uh, definitely, Mohan, definitely. This will definitely help you on that. So, Asim, when we look at, once you buy the course, there are two different kind of course content that you get. Number one is the pre-recorded videos, as well as the recording of the live videos that you will be having the access for lifetime, like for till you are alive, or even after you are alive, you can have somebody else have the ID and password and they can use it as well. But we also have live classes. So those live classes, you'll have the access to. For one particular year, and in that year you can even join more batches if you want. So for example, you join batch number 1, you maybe missed a few live videos, live classes, something like that, you can definitely join the batch number 2 when it starts. So absolutely okay on that. Asim, the certifications, how Kubernetes, it's about more about the certification, not just Kubernetes. Once you have the certification badge, that means that you have a proper credibility to the skills that you're mentioning in the CV. Not everybody is going to be able to clear the certification, because you have to study for it. There is a proper exam in place that you have to give to be able to clear that certification. And once you have that certification exam, certification badge on your CV, that gives a proper clear message to all the HR, hiring manager, talent acquisition managers out there, that okay, this particular guy knows his stuff, or this particular girl knows his stuff, her stuff, and that whatever skills that they're mentioning is in the resume, all of those skills have actually a proper credibility. They have proven that they have got those skills. So that is how the certification helps. Okay. Moving on. So, guys, the learning path for certified Kubernetes application developer. First week, we start with container basics and Docker networking. Then we move on to Docker storage, Docker image, compose, and container orchestration. Then on week number 3, we cover Kubernetes basic architecture, HA, and scalable application. Again, guys, all of these, majority of these modules would definitely have a proper dedicated hands-on labs, like I already have explained you what are those with them. On week number 4, we cover Kubernetes networking and storage. On week number 5, we cover pod designing and multi-container pods and advanced scheduling concepts. On week number 6, we cover Kubernetes monitoring, logging, and debugging. On week number 7, we cover advanced Kubernetes concepts and applications security. On week number 8, we ended up with sample equations and projects, tips and resources for clearing certification and CV preparation. So it's very similar to what was happening before. It is just a slightly shorter one, because again the syllabus or the things that are coming in this particular certification exam is slightly lesser, so it is something that covers slightly early as well. But again, the format is pretty much the same. There are proper topics, you get live classes on that, and on top of that you get hands-on labs for almost all the different modules that are there. Guys, till now, any questions, any doubts, any issues that you guys are facing, please do let me know. I hope I have been answering all the questions, and kind of having those. Alpur, yeah, definitely. Ankit from my team will answer this question for you. Hands-on labs. Again, guys, these are the labs that I was talking about. We start from the very basics by installing Docker, and then we move our, move up our way. Sorry. Then again, similar, we cover almost everything, bootstrapping a Kubernetes cluster using kubeadm. And again, guys, as for the trainer that is going to be teaching you everything, the trainer that you had today, Rohan, so he taught you everything. I see a lot of you guys, even before I was actually asking you guys for reviews, you were giving yourself that it was an incredible session, informative, you were able to understand easily almost everything. So this is the exact same trainer that will be teaching you directly in the class as well. So guys, again, before I move on, please do rate this session out of 5, 5 being the highest, and anything below than that, please do mention the reasons as well. So guys, again, please do rate us out of 5, 5 being the highest. Anything below than that, please do mention the reason. I'm looking at the chat window. I want to see these reviews so that if there are any shortcomings, any things that that we are not able to properly cover for you guys, we want to uh, improve or better in the future sessions as well. So please do mention that. Karthik, can you please be a little more detailed as to which particular course are you talking about, CKA or CKAD, because both of them are slightly different, not majorly different, but slightly different, so we can have a better idea on that. So okay, now Ankit, please help Karthik. Okay, guys, please, again, I'm looking at the chat window. I'm not seeing a lot of you guys commenting as to or putting in the chat window the ratings of it. So please do mention as to what are the how would you rate the session out of 5. We want to know that, so that we get to okay, moving on. Thank you very much for all the people who have rated us 5. Thank you very much, guys. We really appreciate it. Okay, by at the end, we cover implementing network policies in Kubernetes cluster. And guys, that is how we cover everything. Our unique training methodology, what sets K21 apart from all the other different training programs, training portals. First of all, you get free on-job support for 1 year. That means even once you clear the certification, you get a job, still K21 Academy is there to support you for the entirety of 1 year. We're going to be helping you out with whatever doubts, whatever problems you are facing at your work. So absolutely, K21 is there with every step of the way of your new career that you're trying to build in. Then you get free unlimited retakes for 1 year, like I had mentioned before. Once you buy the particular course for the entirety of 1 year, you can join any number of batches you want, and that would be absolutely for free. Second, weekly live interactive sessions. Every week on weekends, you get a chance to attend live interactive classes where it's going to be similar to these, but you will be having much more smaller batches. Today we had more than 100 people on here, but that particular time it would be lesser than that. 25 around is the number of seats available in a particular batch. So you can unmute yourself at any given point and can ask your doubts directly over there. You have videos to learn at your own pace. Like I mentioned, you not only have live sessions, but you also have pre-recorded videos. Then you have WhatsApp and ticketing support system. These are two different things that are set in place with whatever doubts you have, whether it's with the portal, with any kind of emails you're not getting, or any kind of technical content that you're not able to understand. You will always have support from our end to help you with whatever doubts you have. And the response time is under 24 hours or between 24 to 48 hours, depending on how complex the doubt is. Then post-session recordings for lifetime access, like I had mentioned before. job and certification oriented training. The entire goal of this particular certification training is that you, number one, get to clear your particular certification, and second is that you get to have your dream job with you as soon as possible. Sridhar, again, if you take up this course, it is very much subjective on your own individual capabilities as to how much time you're going to take to be able to clear the certification and get a new job in the domain of Docker and Kubernetes. Because again, it is very much subjected to to one's capabilities. I cannot give you a defined timeline, because we have got people who have, once they clear this, once they are done with training program, in under a week or two they are done with their certification and then their job as well. And I've seen people who have taken a slight bit longer than that as well. But we certainly believe that every person learns at their own pace. They learn at their own in their own sweet time, and that's absolutely fine. It again depends absolutely and objectively on you as to how much time you are going to take as an individual. Now, what our students say, again, these are just a few testimonials. I'm just going to cover one or two out of these. We've got Narendra here who says, "Hi team, good news. I passed my CKA exam today. I come from a non-technical background and follow the material. If I can do it, anyone can do it. The exam prep questions were very vital." We have Nitin here. Happy to announce that after a lot of practice, could pass the CKA certification. Thanks K21 and others for all your support on my time to time queries here. It was not easy one being from network background, but with efforts and a lot of practice could achieve it. Funda in all the people who are not Indians. Funda is the word. Funda means the proper basic ideology is to practice as much as you can all the different concepts. Again, guys, these are just individuals like yourself who one day would have stumbled across a free live webinar and taken up K21 Academy's CK or CKAD course. And these are them. Oh, I'm sorry about that. These are them sharing the screenshots of their particular certification. Now, guys, for all the people who have never seen the CKA, certification, this is how it looks like. And again, date of completion, certification number, everything is going to be mentioned like this. These are again all the different students of K21 Academy who have cleared their own individual certification exam, and once they do it, they tend to share their certification screenshot with us, so that people just like yourself who are aspirants, as we would like to call them, towards clearing this particular certification can get a lot of motivation from it, that if they can do it, absolutely you can do it as well. Michael, there are no, as of such, any major prerequisites to take the CK certification, as long as you have the dedication and you've got the knowledge to clear, to whether it's theoretical knowledge or the practical knowledge to clear the certification, you can very well clear the certification as well. Again, guys, I believe you guys are quite, how would I say, quite a testament of how the session was. But again, these are individuals like yourself. These are actually our learners who rate us, out of 5 every time a session is done. So again, you have yourself rated us, so you would know how these sessions are yourself now. Now, this is the second step I was talking to you guys about. A lot of you guys are asking about the price of the course. You're talking about a lot of different things, asking a lot of questions on that part. So this is where you get the answers to a lot of them, and also get to learn a few other things that were not covered here. So guys, again, make sure you go and register for this free class at k21academy.com/K8S02. There's a lot of different things that we were not able to cover today because of that time constraint, but no worries at all, because that will be covered over there. Again, guys, a very, very important thing. It is absolutely for free. If you guys enjoyed today, you would absolutely love what is going to be happening in this particular free class as well. k21academy.com/K8S02. Go and register right now. Or not. I'm looking at the chat. Go right now at K21 Academy K8S02. I see a few of you guys have already done it, but I want to know whether you have cleared this register for this free class or not. I'm going to stay here for a little bit before I move on. But in the meantime, I want you guys to go ahead right now and register for this free class. It's going to be very, very beneficial for you guys on that part. Absolutely, Saint Dix. I don't know actually if this is your real name or just a made up name, but or if I'm pronouncing a name wrong, I'm really sorry. But can someone new in IT networking sector start this program? Absolutely, 100%. I have shown you one screenshot that somebody had mentioned that he that person was a no somebody from a non-IT domain. Then also they were able to clear that certification. So if you are from IT domain, that actually gives you a little bit of an edge over them. So absolutely, Sent, you can definitely enroll in this training program even if you are new into the IT domain. We even have people who are still in college, young students still doing their bachelors, coming up and enrolling in this training program and eventually clear the certification even before their college is over. So absolutely, 100%.
Shivans, if I may, can I take a couple of questions?
Absolutely, sir. Absolutely.
Yeah, there's one question which I wanted to answer is the one which Sridhar asked. I'm a DBA. I'm a relational and NoSQL DBA. How is learning CKA or learning Dockers or containers or Kubernetes going to help me? Well, the reason I wanted to pick the question is I used to be a DBA myself. I spent close to 17, 18 years being the DBA and database architect. Well, the containers are here to stay. Like it or not, everything is going to get containerized. The way it started off, it was for the stateless applications. And now the stateful applications like your databases, we can run them in your containers as well. So you looking at the legacy applications and legacy databases right now, in a couple of years from now, everything would be running in your containers. So it definitely is going to give you a jump start. And if you are ahead in the game of you know how to run your containers, it's definitely going to help you. There are many images. If you go to Docker Hub and search for like any popular DB out there, MariaDB, MySQL, Mongo, Cassandra, you will find the images and you can conveniently run them as containers as well. Looks and feel exactly like the way you are running on your server that's running in your container. Right. So from that point of view, you should definitely take a look at what containers are all about and try to understand about the Kubernetes for orchestration part as well. There's also one more question I want to take, which said, does it require a programming knowledge for me to be an administrator of Kubernetes? Absolutely not. Zero. You don't need to be a programmer. Administration is managing of your cluster, ensuring it is up and running, upgrading, patching, and taking care of that. From CKA point of view, you don't need any programming language. Zero is what it takes. And what are any prerequisites for me to take up these Kubernetes course or Docker container course? The only prerequisite is you should know what computers are. And if you know that, it should be more than enough. You don't need to really have an in-depth knowledge of Linux or Windows or kernels or any of those. Absolutely not. A basic computer literacy, if you know how to log into your computers, spin up your shells and stuff like that, that's more than enough for you to learn. There was one more question which Shivans was answering is like, I'm new to IT and networking. Do I need to do it or not do it? Like I said, everything is getting containerized. Application needs to run somewhere, and either your servers, your virtual machines, your containers, somewhere they need to run, and containers are catching up real quick. We looked at the Docker numbers, the amount of billions of downloads of images, what we've seen. So if you're in IT, you're running your networking softwares, though also will be running in your containers. So it's going to add an advantage for you, an edge for you to learn your containers and Kubernetes. With that, I will hand over to Shivansh. Thank you so much, dear.
Thank you very much, sir, for answering this. I don't think I would have answered even nearly on that part. So I hope, Sridhar, this answered your question. And guys, again, I hope all of you guys have already registered for this particular free class. As for you, Claudio, again, the average salary package, everything is going to be covered in this particular training program. Not answering your particular question because I don't want to give you any spoilers. There's a lot of other things as well that you should be looking out for these things. But again, I think we had already covered you a little bit of a ballpark. It's around again, it ranges between $75,000 to $150,000 or $100,000 US dollars again. But again, it depends upon how much experience you have, how much skills you have, how much job experience, and you have done individual projects on the same. Nilesh, no, like sir mentioned as well, and I've showed you a proper dedicated screenshot where a person was coming from a absolutely no IT domain where they did not had any sort of experience in this particular space. Coding is something a much more farther option on that part. They were even able to clear the certification, so it's absolutely clear that you do not need to have any prerequisites, let alone having a coding prerequisite on that.
The
Okay.
CKAD is kind of
Yes,
sorry,
sorry, sir.
Shivansh.
Sure, sure, sure.
The CKAD is more focused in helping your developers deploying and letting you learn concepts around deploying and new applications and stuff around that. But CKA is more focused towards administrators, which lets you how to manage your clusters. That's the subtle difference between those two. From that point of view, you don't need to know any operating systems or any programming language, none of those. Thank you, Shivansh.
Okay. So we've got a question from Biswajit. Can we use it without command and only through application? Hello. Sir, I think
Sorry
you're
about that. I was
still.
talking on mute. I'm sorry about that.
No,
Yes, you
that's
can. You can. The commands what you run also get converted behind the scene as your REST APIs and get posted to your API server. Well, you don't want to make use of commands, no problem. Make use of GUI. You don't want to make use of GUI. I want to talk to my application to directly talk to my cluster. You can do that as well. You can do the REST API posts and you can take care of that.
okay. Asim, yes, definitely, why you can get a job even without any experience, because even an experienced person will someday once a fresher. And along with this particular course, we do help you with your CV prep. That means every job opportunity that you are planning to apply for, we would definitely help you with getting your CV prepped up for that particular job role. Because every job role or job opportunity that you apply for, it is highly recommended, and from our end, assisted you as well, that you need to create a new particular CV that perfectly matches that JD, that is also called job description on the same. So don't worry on that part, buddy. Okay, guys, we are almost at the end of this session. Make sure you subscribe our YouTube channel. Just go at K21Academy.com. The last time slash YouTube, or just go on YouTube and search K21 Academy. We have got tons of different things. We've got a small little podcast that we were doing before, a lot of different free playlist on different content, whether it's Ansible, Python, Azure, Kubernetes, Dockers, and a lot of different things. So make sure you go and subscribe there, and make sure you join our Telegram community group. It's absolutely for free. You get to meet aspirants just like yourself, and we post about different free classes, different sales that are going on, absolute free blogs, and a lot of other different stuff. To join this particular community, just go at k21academy.com/k88s community. I'm just gonna wait for a few seconds more so that you can have a look at this particular URL. And once you click on, once you Google this, you will definitely get the access to your particular to this particular group on Telegram. So again, guys, make sure that you join this community group. It's absolutely for free, and there's a lot of different things that goes there, whether it's discussion. It also have both our paid members as well as the new learners that are just finding out about us. Michael, a lot of these things have already, like I mentioned, are going to be answered on the different other webinar that I told you about, K8S02. So make sure you k21academy.com/K8S02. You make sure you go and do that, and definitely we would be helping you guys with building your CV as well. So don't worry on that. And thank you very much, everybody who have mentioned that they like the session. I hope you guys find it beneficial and you learn something new. Make sure you follow us on all our social media platforms. And it's a humble request and a big, big, big suggestion that you go and attend the free live webinar that I directed you towards. If you are even interested on the particular uh, in your particular kind of um, in the particular course, I'm sorry about that, even in the particular course, you can very much cover all the details of the course. What are we covering? The hands-on lab dedicated to that particular course, the price, the bonuses that you get, everything is going to be mentioned in this particular free class at k21academy.com/K8S02. So just make sure that you attend that particular, free class, because again, if you are not taking the next step, you will definitely be missing out on some proper good stuff. Sure, Asim, I'll just put it there. Okay, oh, I'm sorry, this is not the link. This is the link. So yeah, I put it there, guys. Again, thank you very much, and I'll see you guys directly in the next particular free class that we'll be doing. So thank you very much, guys. I'll see you guys again.
Thank you. Thank you
Thank
so
you
much,
very much.
Sh1. Thank you everyone for rating us so high. And I saw most of us, all of us have rated 5 out of 5. It's brilliant. It's awesome. Thank you so much for your motivation. Thank you, Sh1. It was wonderful. See you around.
Thank
Take
you.
care.
Thank you very much. So bye bye.